Okay, so any exponential function is always going to be in the format f of x equals a times b to the x power. We call it exponential because of that variable in the exponent. In this, a always represents the initial value, how much the function has when it starts at 0, and then b is either the growth or decay factor, depending on if it's getting bigger or smaller. So growth/decay factor. So to write a exponential model, we need to know the a and b value. So I'm going to do number 3. For number 3, I'm going to look and see what the a and b value are so I can write my model. So what I'm going to do is I'm going to see what am I multiplying by each time. That's going to be my, well, in this case, decay factor because I'm getting smaller. So what I do is in my calculator, I do 0.2538 divided by 0.846, and that gave me 0.3. So that means I multiplied by 0.3 to get from one number to the next. And if I double check, 0.2538 times 0.3 is 0.07614. So my decay factor is 0.3. To know the initial value, I need to work backwards in my table. I need to know what matched up with 0. So I'm going to go backwards to 1 and to 0. I'm going to do that by dividing by 0.3. So if I do 0.846 divided by 0.3, I get 2.82. So when x is 1, the function's 2.82. And then I divide by 0.3 again to get 9.4. So when x is 0, f of x is 9.4. So that means that my model is going to be f of x equals a, which is 9.4, times b, which is 0.3, to the x power. That's my exponential model. For the next problem, I need to see what I'm multiplying by. If I do the same trick to find b, I divide 5,376 by 336. That gives me 16. But if I look closely, that's for 4 years. So I multiplied by some number 4 times, and I got a total multiplication of 16. So that meant that I must have multiplied by 2 each year, because 2 times 2 times 2 times 2 4 times is 16. So that would give me my total 16 increase. I also need to work backwards to year 0. So I'm going to divide by 16. I'm going to divide 336 by 16 to get 21. So at 0, the population was 21. So that means that my model, my function, is f of x equals 21 times 2 to the x power. So they want to know the rate that my percentage is increasing, or the percentage that my population is growing by each year. So there's 2 formulas. If it's growth, to find r, I do b minus 1. But if it's decay, to find r, I do 1 minus b. So it depends on the function. Since this is growth, I'm going to do r, the rate, equals b, which is 2 minus 1. So r is 1, but r is really a percentage, so 1 as a percentage is 100%. The population is increasing by 100% each year. And then they want us to determine how many people lived in the city in 2010. Well, t, or x, the time, is years since 2000. So this is 10 years since 2000. So I'm going to do f of 10 to figure out 2010. Is 21 times 2 to the 10th power. Which, when I put that in my calculator, gives me 21,504. So that'll be the population in 2010. So in order to be considered growth, exponential growth, we have to have a factor that's bigger than 1. In order to be considered decay, our factor has to be between 0 and 1. So if I look at 7, 3/4 is my factor. 3/4 is between 0 and 1, so that's decay. And then if I look at 8, my factor is 5/3. 5/3 is bigger than 1, so that makes this one growth. So for the next problem, this has a factor of 5.6, so that makes it growth with a factor of 5.6. Since it's growth, I need to do b minus 1 to get the rate. b minus 1. So my rate is 4.6, which really should be a percentage. 4.6 as a percentage is 460%. And then the initial value, the a value, is 4.